All right, this fifth video talks all about our chemical properties and reactions and how they're different from the physical properties and reactions that we see of our matter. A chemical property is an ability to undergo a change, but it transforms it into a different substance. So when you burn a piece of paper, it's no longer paper after it burns. It is now ash. When wood rots, it is not going to go back and make wood. When metal, iron rusts, or when something decomposes or ferments, it's not going to go back to explode. It's really hard to get these sparklers to go back to the way that they were. Okay, if you overcook your eggs or overcook your meat, you can't put it back into the refrigerator and uncook it and make it less burned. All right, they are irreversible. And that is the big difference between a chemical and physical property or change. All right, so these things are not going to go back. Okay, a chemical change is also known as a chemical reaction. And we're going to spend the second half of the year really talking about chemical reactions from chapter 8 on. All right, so reactions are going to be when you have starting reactants that change into products. And the yield sign is the arrow. We read from left to right, so our reactants change into products from left to right. And you'll see the arrow points from left to right. So remember how I said learning all those chemical symbols are really important? This is why. A chemical reaction tells you a sentence, and it would take a lot of time to be like 4 iron atoms that are solid and 3 oxygen molecules that are gaseous will react to make 2 iron 3 oxide compounds. All right, so that's a lot of words. But if we say Fe for iron, O2 for oxygen, and Fe2O3, which is the chemical formula for the compound rust, it's really easy to write that down. Okay, it's like our little shortcut, our little language that we use. You'll also see that there are numbers in chemical reactions. These numbers out in front, these 4, the 3, and the 2, those are coefficients like in math class. They tell you how many atoms, if it's an element, or how many molecules, if it's going to be a compound, are going to be in that chemical reaction. You'll also notice there are these little small numbers right here. Okay, these small numbers right here are called subscripts, like a subway below the line. So they are below the line of type. They are the number of elements in that compound. Okay, you know all about H2O. It has 2 hydrogens and 1 oxygen. We don't write the 1 because it's implied to be there. So Fe2O3 means you have 2 irons for every 3 oxygens in this compound. There's also FeO in a 1-to-1 ratio. So you have to be careful that you get the subscripts correct so that you're talking about the proper substance. Okay, you'll also notice that in that chemical reaction, there are a couple more letters, and those letters are going to be in parentheses so that you don't confuse them with the compound or with the chemical symbols that you already learned. So you'll see that there is an S, which means that you are looking at solid iron. There is a G in parentheses, and it's lowercase, and you'll see that that is a gas. And you'll see that there's an S over here as well because you are going to make rust, which is going to be solid. So when you are doing a chemical reaction, if this said that you were making a gas, be careful. It's going to bubble and it's going to pop up at you. All right, but if it is a solid, oh, that's probably going to fall down in my solution. You'll notice this chemical reaction doesn't have L in it. But there does exist an L, and that is for your liquids. But be careful. It's only water, mercury, and bromine that are pure liquids. Everything else is aqueous. And we don't get into this in the textbook until chapter 12 or 13, so I like to introduce it right here. All right, aqueous, aqua, means it's a solution made with water. most of the liquids that you're going to deal with in our labs and in our class are going to be liquids. And those liquids are not pure liquids. They are aqueous solutions. So the hydrochloric acid that you use and the sodium hydroxide that you use, this is a acid-base neutralization reaction. The H and the OH from here make water. Oh, look, that's going to be your pure liquid. And the Na and the Cl is going to make NaCl. Hey, that's salt water. So a nasty acid and a nasty base are going to make salt water and neutralize each other out. Science. Okay, all of these chemical reactions all obey a fundamental law, and that is the law of conservation of mass and matter. And when you get to physics next year, we'll add in energy as well. All right, and that law states that mass is never created or destroyed. It's only transferred or transformed from one side of the equation to another. So remember, there's a left side and a right side. There are reactants and there are products. Okay, so the number of reactants, the number of products have to equal one another. All right, so that's why we have these coefficients and these subscripts to help everything even out. So this is how water is formed, and it's very easy for water to be formed. We'll form some in class. I'll show you. How we take two H2s, so that means 1, 2 for H2, and then I have two of them. So how many total hydrogens is this? That means there are 4 hydrogens over here. And we take an O2 molecule, so that's 1, 2 of those. And we make 2 water molecules. And water is H2O. So let's count up. 1, 2, 3. There's 4 hydrogens. And there's 1, 2 oxygens. Huh. That's the same on the left and as on the right. So that means that we obeyed the law of conservation of mass and matter. All of our chemical reactions are going to have to do that. And in Chapter 8, we will spend lots of time balancing them, putting the coefficients out in front so that we do accurately represent what is happening in nature. All right, so the last little bit of information to go over in our chemical reactions is how do you know it's a chemical reaction and not a physical reaction? Well, there are 4 pieces of evidence to look for. All right, so the first is that there is some sort of energy change. It's going to heat up, it's going to cool down. Energy is also a sound or light that's given off. Okay, there is a change in color. Okay, how can you tell the difference between raw eggs and cooked eggs? Well, the color change. It goes from opaque um, to that white color, all right? It makes a gas, and gases are fizzes, bubbles, a smell, something like that. But the biggest way to tell is irreversibility. You can't go back. And that, ladies and gents, is chemical reactions.